Every year, software breaches cost organizations trillions of dollars, and most of them aren't caused by genius hackers. They are caused by the same five mistakes that have been on the OWASP top 10 list for over a decade. SQL injection, hard coded passwords, missing input validation. The fix is well known. The problem is that finding and providing these vulnerabilities cost up to $50,000 per audit and takes weeks. We built Agentinel to do this entire job: find, exploit, fix, and prove in minutes. Hi, I am Somya from Team Agent Forge, and this is Agentinel, or an autonomous vulnerability detection and real exploit confirmation, AI generated patches, and human oversight built in every step. So, a single AI model can't do this well. Security analysis requires complete different types of reasonings. Finding weaknesses is creative, confirming them is empirical, and patching is precise. And verification is adversarial. If you ask one model to do all four, you get mediocre results across the board. So we build a five specialized agents using the Google ADK, and which performs in which each performs one job. And the critical insight is this: one agent's output becomes the next agent's test, and that's adversarial chain is what makes Agentinel trustworthy. So we built Agentinel entirely on Google anti-gravity environment. You can see here, anti-gravity helped us scaffold the multi-agent pipeline, bias the MCP boundaries, and build the custom hacker themed Streamlit UI and debug the evaluation logic. So all those natural languages, it was our pair programmer for the entire build. What would have been a team weeks was done in one focus session. Agentinel is fully deployed on the Google Cloud Run. Here is the public URL. Anyone can test it right now, and the complete source code is open on the GitHub with full documentation, a Docker file, and one command deploy. So under the hood, the Grok API running the OpenAI GPT-OS 120p model for LLM reasoning, Streamlit for the UI, Docker for containerization, and Google Cloud Run for deployment. And five agents, one MCP server, zero compromises on security. Let's see it live and here on the deployed link. So right now this is our interface, which is a hacker themed interface, and we already have a deliberately vulnerable code written here. So let's execute the scan sequence. So the Recon agent is live, and it's scanning the AST, running heuristics analysis, and querying the Grok API. So one critical vulnerability found, then the another critical vulnerability found, and this is how it has found the five vulnerabilities here. It's six vulnerabilities. So now the attack agents come under action. It generates payloads, watches the MCP sandbox, execute them in real time. So now the patch agent drafts a fix. It switches the parameterized query, the industry standard defense. So let me authorize the deployment of what changes needs to be made in the particular code. So now it moves to the verify agent. But notice one thing: the system stops. It's not applying anything automatically. This is the human in the loop gate, and it's a hard security boundary, not a checkbox. So this process is continuously done until all the patches are fixed, and the verification agent takes the exact same payload that just succeeded through the same MCP sandbox. So the same attack, same payload, different result. This is not a claim, it's a proof. Most security tools tell you a vulnerability is fixed. Agentinel shows you that before and after verification is what makes the system trustworthy.
So the whole process is completed. We have found 6 vulnerabilities, 6 times the attacks were fired, and 3 times we fixed the patches. So right now we can download the corrected and fixed Python code from here by clicking on the installation button, and that's how the whole process works. Thank you.